Welcome back, friends. Today's lesson is all about classifying quadrilaterals. Here's what you're going to need for today's lesson. Think. What do you know about quadrilaterals? Perhaps you know that they all have four straight sides. Some examples are squares and rectangles. Let's look at problem 1 on our problem set. Here, it's asking us to construct a quadrilateral with at least one set of parallel sides. Let's start by drawing a straight horizontal segment. Next, let's use our right angle template and our ruler to draw a segment that's parallel to the first segment. If you can recall from a previous lesson, we do this by lining up our right angle template below the horizontal line we just drew. Then we use our ruler and place it flush along the other side of the right angle template, like this. Next, applying pressure, we slide our right angle template down along the ruler. We can then draw that second line, which will be parallel to the first one that we just drew. Next, we draw a third segment that crosses both of the previous segments. Finally, we draw a fourth segment that crosses both, but does not cross the third segment that we just drew. Take a moment to compare your quadrilateral with mine, looking at angle size and side length. For example, I noticed that my quadrilateral has both one obtuse angle and one acute angle. It also has two right angles. What do you notice about yours? One thing is for certain, all of our quadrilaterals have at least one set of parallel sides, which means all of our quadrilaterals are trapezoids. Say that word with me. Trapezoids. Perhaps some of your trapezoids might have other familiar names, like rectangle. Go ahead and pause the video here, and I'd like you to construct two more trapezoids for problem 1. We'll compare our trapezoids when you return. Welcome back. How did you do? Here are the other two quadrilaterals I constructed. Let's take a look at this first one here. Can you identify two parallel lines in this trapezoid? It would be this line segment and this line segment are parallel. What about in the third trapezoid I drew? Can you identify two lines here that are parallel? This one actually has two. This line is parallel with this one, and this line is parallel with this one here. Under problem 2, let's construct a quadrilateral with two sets of parallel sides. We'll start by drawing one set of parallel segments, the same way we did in problem 1. First, we draw a straight horizontal segment. Then, we use our right angle template and ruler to draw a segment parallel to that segment, just like before. Next, draw a third segment that crosses both. Finally, using our ruler and the right angle template, let's draw a fourth segment that crosses the first two segments, and that's also parallel to the third segment that we just drew. Take a moment to compare your quadrilateral with mine. Think, are these shapes drawn in problem 2 trapezoids? They may not look like the trapezoids that we drew previously. Remember though, that a trapezoid has to have at least one pair of parallel sides. So what we just drew is indeed a trapezoid. We call quadrilaterals with two pairs of parallel sides parallelograms. Let's record that word for problem 2. I'd like you to pause the video here now to construct 2 more parallelograms for problem 2. I'll see you back here in a bit. Welcome back. Did you happen to notice that some of the quadrilaterals in problem 1 and 2 are the same? Let's take a look. Remember, that's perfectly fine if they look the same as the ones from problem 1. A trapezoid must have at least one set of parallel sides. A parallelogram is a special trapezoid. It has 2 sets of parallel sides. For problem 3, we need to make a parallelogram with 4 right angles. What do we call 2 lines that intersect at a right angle? We call them perpendicular lines. Let's begin constructing. First, draw a straight horizontal segment. Then, using your right angle template and your ruler, draw a segment that's parallel to the first segment that we just drew. Next, draw a third segment with a right angle perpendicular to the baseline. Finally, draw a fourth segment that is also perpendicular to the first segment. Take a moment to compare your quadrilateral with mine, looking at angle measured and side length. Here we can see that the fourth segment is parallel to the third segment. It also has 4 right angles. Let's identify with a square in each vertex. These quadrilaterals that we just drew have 2 sets of parallel sides, so they're parallelograms and trapezoids. However, our figures have another special attribute. They all have 4 right angles, so they're called rectangles. I'd like you to pause the video here to construct 2 more rectangles for problem 3. I'll see you back here in a bit. Welcome back. Here are the other 2 rectangles I constructed. Great work so far. Let's continue with today's work. Problem 4 requires us to draw a rectangle with sides that are all the same length. First, draw a straight horizontal segment. Then, use your right angle template and your ruler to draw a segment that's parallel to the first segment. Next, draw a third segment with your right angle template that's perpendicular to the baseline. Let's now measure the length of this third side. Once we have the measurement, we'll mark that same length on both this segment and this segment. We can see that segment, the third segment for my drawing is 3/4 an inch. Finally, draw a fourth segment perpendicular to the first segment through those marks. What did we just construct? You're right, it's a square. A square is a special rectangle and has all sides of the same length. Remember, if a square is a rectangle, then a square is also a parallelogram and a trapezoid. For today's assignment, your must-dos are here on the screen. Go ahead and set a timer or watch the clock for 10 minutes to complete this work. I'll be here when you get back. Today's lesson was all about classifying quadrilaterals. Great work for today. Be sure to check in with your teacher, and we'll see you around here soon for another Eureka Math lesson. Bye.